Hello everyone, welcome to the new tutorial of coding techniques. Today we are going to cover memoization. If you don't know what that is, it is a programming technique that helps you to cache the result of existing input in your program so that you can reuse that result again and again if you need to, and so that you don't have to compute it. So basically you save the computer resources that way. And today I'm gonna demonstrate that with an example from Fibonacci sequence. So in this you need to find out what is the value at a particular index. So for example, if your program is asking you what is the value at index 5, then it will be 8, and what is the value at index 6, it is 13, and what is the value at index 7, it is 21. So Fibonacci sequence follows the formula that your value at any index is the sum of previous two values. So you see the value at index 2 is the sum of previous two values, and the value at index 3 is sum of previous two values. So similarly the value 21 is sum of 8 and 13, so previously calculated values. And this is the formula for this. And if you write this program this way, so I have written this program recursively where you pass a number and it does the calculation that I just showed you above. But if you follow this, what happens? So let's have a quick walkthrough what the program is doing. Let's say you pass 4 as the value of index, and it comes to this point and it says, okay, this is not meeting the criteria. Then it goes ahead and it goes to Fibonacci number, then it passes index -1 to this method, and then passes index -2 to method again, so basically calling itself. So if 4 is passed as the index, then it passes 3 to this method and 2 to this method, and now 3 is passed to this, and then it further passes 2 to this method and 1 to this method. So if not, you noticed what it is doing every time, it is kind of branching out the computation for the same number again and again. So it will be recomputing the result of 3 two times, result of 2 more times. So it will just keep on doing it, and if you grow the input size, it will grow the execution number of this algorithm exponentially, and there will be a time where you will not be able to get a result. That I'll show you how. So in this technique we are not caching anything, but if we use memoization, it means you cache the results and reuse those. So have a look at this method, find Fibonacci number with memoization. So you pass index 4 to it. So what it does, it checks if the calculation for index 4 already exists in a map. So I have taken this map of integer to integer, basically storing the result of number at particular index. Okay, so let's go through this method that is using this map to cache the result, and it checks if in our example we took 4 as the index, and if 4 is found within this map, then we just return the result. We don't have to do the computation. And if that is not already computed, what we do, we call this method again, and then it is called for 3 this time, index -1. So 4 minus 1 is 3, and then 4 minus 2, 2. So it calls it for 3, and then when it calls it for 3, it again calls itself for same function with value 2 here. And what happens in that case, if you remember, when it was called for index 4, then it already made a call for 2 here. So in this case 2 calls are going to the Fibonacci series method, and when computation for 2 was done in one of those calls, then it caches the result, and next time when system is calling this method again, we just grab the result from here and then return it. So what will happen then, in one of the scenarios, this method will be just returning the cached result instead of computing and going through the entire chain of branch of computations again and again. And this is how you're gonna optimize your program. So I'll just show you by running this program. So you see, okay, so what I have done, I have passed index 30 for now. Let me pass a small index for now just to demonstrate it. And here we go. So I passed index 5, so number is 8 at index number 5, but without memoization it is taking 15 steps, and with memoization it is taking 9 steps. Let's increase this input to 10 and calculate it. So you see the number of steps of calculation is 177 and the value is 89. But in case of memoized function, the steps count is 19. So this is what I'm doing here. I'm just calling these two methods one by one and then printing the steps. And you can see the result yourself, and I'll just show you what if you pass let's say 30 to it. So pass 30 to it, and then you will see the number is huge, and then number of steps that it is taking to count this number is too high if you don't use the cached result. But if you cache your result, then this is just taking 59 number of steps of execution. So you can see this is exponentially growing the algorithm, and there will be this time if I call it with 50 as a number, it will be just running into all the exponential complexity algorithms, just branching out itself multiple times and not able to actually complete the calculation. So you will see, so you can see it is still going on. It is not yet done. So let's wait for it, and I think it will not be finishing it, or it will be just timing it out. So now you know what is the benefit of using this caching technique, and you will see that in the programs wherever you can just make use of existing result, you can simply use memoization technique, cache the result, reuse it, save computing time, and it can reduce the complexity of your algorithm from exponential to maybe constant in some of the cases, or something better, and better, definitely better than the exponential time. That's it for today's video. Thanks for watching. See you in the next one.